Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 392 is subsequence. This is an easy level Leetcode problem, and in this problem description we're told that we're given two strings s and t, and we need to return true if s is a subsequence of t or false otherwise. And we're told the definition of a subsequence is a string whereby a new string that is formed from the original string. So where we got a string and we can create that string is created from an original string by deleting some of the characters without disturbing the relative positions of the remaining characters. So in this example, ace is a subsequence of a, b, c, d, e, because if we ignore b and d, we get a, c, e. So ace will be a subsequence, whereas aec is not, because it does not. Although we can make those, say we can make ace from aec, or sorry, we can from a, b, c, d, e, we can make aec using the exact same amount of characters. We can see that it does disturb the relative positions of those characters, so it needs to be in order, in a linear kind of order. So that's the way we need to solve this problem. So how are we going to approach this? Well, the best way to approach this problem is by using a two-pointer solution. And simply what we're going to say is, let's start off at either the beginning of either or both of our strings. Actually, we're going to have 2 pointers. Let's call them 1 and 2, and we're going to move our pointers. So let's say we move 2. Once we move 2, we're also going to move. We're going to move 2, and we're going to say, is it equal to, or is a and a equal to each other? Are the 2 pointers equal to each other? And if they are, we're going to shift both pointers to the right. If not, we're only going to shift the pointer of the original string from which our subsequence is derived from. And so let's say we go to a and a are the same, so we shift our pointer. We shift both our pointers. H and b aren't the same, so we shift our pointer again to b for our original string. B and b are the same, so now we shift our pointer to c, and then we say, is G and C the same? G and C aren't the same. Is D and C the same? No. Is C and C the same? C and C are both exactly the same character. So now we get to the end of string S, and we also get to the end of string T. But there are cases when we won't be able to make a subsequence from the original string. And in that case, we'll get to the end of our original string, but we won't get to the end of our subsequence that we're given. And so we want our base case to be, if we get to the end, so if we get to the end of either the length, so either the length of t, or if we get to the end of s. So if our pointer is greater than the length of t or s, that's our case, which means we then stop our while loop, stop shifting those pointers, and we return the result, basically. So let's get straight into coding this problem up, and it will make more sense, as always, once we've started coding this problem up. So let's create our 2 pointers, L1 equal to 0, L2 equal to 0. And like in our case, we said we're going to say, while L1 is less than, we'll say L1 is going to be the length of t. We're going to start off as if we're starting from our original string. So while L1 is less than the length of t, and actually I said or, but we should have said and. So L2 is less than the length of s. So we know that we are in bounds for both of these. We're going to say, if TL1 is equal to SL2, well, now we've found that both characters are the same. So we can shift both L1 by 1, and we can shift L2 by 1. Otherwise, we're just going to shift L1 by 1, because L1 is the pointer for our original string. And then what we're going to return? Well, we're going to return is L1, or sorry, is L2 equal to the length of string S? Because if it is, it means that we have gone through all the characters in length t, and we've figured out that we can make our subsequence from those characters. So let's actually run the code and let's check that works. And it does, and we pass all 22 test cases for this problem. So it's quite a simple problem. It is a Leetcode easy at the end of the day, but it can confuse you a bit, especially if you don't recognize that this is a two-pointer solution. So this is a two-pointer solution, guys. In terms of time complexity, well, time complexity is going to be equal to O of t. So it's a linear time complexity where t is obviously going to be the length of string t, and then our space complexity is simply going to be big O of 1, because we're only using 2 pointers as our auxiliary variables. So with that being said, I hope you guys enjoyed this video, and I'll catch you very soon.